Today I'll be teaching you how to use Punnett squares. So first, what are Punnett squares? Punnett squares are used for determining the trait outcome of breeding two organisms. For example, what hair color will the offspring of a red-haired man and a brown-haired woman? The outcome will be expressed in percents. Before we get to doing Punnett squares, you'll need some background information. Punnett squares are named after Reginald Punnett. Punnett first explored the possibility of using this kind of graph, shown right here. With Punnett squares, there are some basic terms that you need to know. These are allele, the different forms of the genes. These come in two types. Dominant, which is expressed by an uppercase letter, right here. The allele that expresses itself when paired with a different allele. And recessive, represented here. That is an A. I'm not good with the paint. The allele that does not express itself when paired with a different allele. Heterozygous, which is what this pair is right here, having mixed alleles. Homozygous recessive, having both recessive alleles like this. Homozygous dominant, having both dominant alleles. So as you can see, heterozygous means you're mixed, and homozygous means you have both of whatever type it says. Codominance is when both traits express, say there's one trait for an animal having a blue spike and another trait having it have a green spike, and the heterozygous one just has both, so that creature has a blue and green spike. Incomplete dominance, the heterozygous combination has a distinct trait, different, it's a combination kind of the dominant and the recessive. For example, if you have a white flower and breed it with a red flower and it has incomplete dominance, the color for the heterozygous ones might be pink. And then you have genotype with the allele percent. What the allele type percent makes the outcome, i.e. 50% heterozygous, 50%, and so forth. Phenotype, what the physical outcome is shown, i.e. 50% brown hair, 25% blonde, 25% black. Now onto the actual square. The square is set up by making a box and dividing it into 4 sections, just like this. The male alleles go on top, and the females on the side. You simply pull them across. You'll get the outcomes in each box. Each box represents 25%, so just add up the matching percent to get the genotype. Doing the same, but replacing the allele combos for what the trait they represent, and you get the phenotype. Record both of these on the side or below. So I'll give you guys an example now. Let's have a heterozygous male and a homozygous recessive female. I just like using A's because they're kind of simple, easy to use. And when I say pull them across, I just mean like this. Since these two boxes match up, they go there. Since these two boxes match up, they go there. Just like that. It's pretty easy, pretty simple. Anyone can really do it. It's quite useful. You can do them pretty quick. And what I was saying about phenotype and genotype, I'll show you that now. Since we have two here that are heterozygous, it would be heterozygous 50%. And since we have the two here that are recessive, right here and right here, it would be homozygous recessive 50%. And let's say this was the flower I was talking about earlier with having pink and white and red. That means it would be 50% pink because it was incomplete dominance, and these two had the mixed genes, so. And then 50%. Oops. Still holding shift. 50% white for the recessive. So yeah, just as simple as that. Now I'll give you another example using codominance. Codominance is a bit more tricky since you actually have to be careful about, what it is. I'll just quickly draw a new Punnett square so this example can still stay up. And the squares, they don't really have to be exactly squares, it doesn't matter. As long as it has 4 boxes, it's okay. Alrighty then, okay. Let's use the spike analogy I had earlier, and we'll just put S for spike. Your alleles usually, whatever you have for a letter to represent them, usually represents something related to the gene. So both of these parents are heterozygous. So with heterozygous, it means with incomplete dominance that they have, codominance, that they have both purple and green spikes. So just drag them across. Doesn't matter which allele comes first, usually the dominant one will. And there. We're done with that. And now back to the genotype would pretty much be the same as the last one, same concept and all. But I'll type that out anyways. It would end up being homozygous dominant. I'm just gonna write D to shorten it. 25%. Homozygous R for recessive, 25%. And then finally, heterozygous, it would be 50%. It's not really different from the last one, it's just the same concept. I'm gonna now do phenotype where things do change a bit. Because with codominance, all the traits express. Even if they're recessive, even if they're dominant, they all express themselves. So it would end up being 25% having, let's say, green for the dominant, 25% purple for the recessive, and then 50% are the lucky people who have a spike that has both colors on it, just split in half. So in this case, the heterozygous is more common because you had 2 heterozygous parents. So yeah, that's pretty much it for Punnett squares. So there's not much more to it. You just line them up, pull the alleles across, write down your phenotype, and write down your genotype. That's it. Pretty easy, and I hope you learned from this.